Hey there, math friends. Today we are taking a look at Topic 6, Block 6, more on exploring rate of change in motion problems. And we're taking a look at this graph right here. You can see it's using distance from a motion detector and time in seconds. And what they want us to do here is build a table of values from this graph of a skateboarder moving in front of a motion detector. So you're going to want to real quick sketch out a table that goes from 0 to 10 seconds, and well, here it goes. Now, as you can see, I did not complete the table, but you certainly can. You'll need to add on, 4 more blocks down here. Yeah, it just gets sloppier and sloppier the more I try to do. Anyway, there we go, there's our 10 seconds, and we want to record the distance that the skateboarder is from the motion detector. And so at 0 seconds, you can see he is at 1 foot from the motion detector. At 1 second, his distance from the motion detector is 3 feet. At 2 seconds, 5 feet. 3 seconds, and you're just going to keep going, filling in this chart this table based on your graph. So go ahead and pause the video and take a few moments to finish your table so that you're ready for the next activity. Go. Okay, now that you've completed that, you'll want to use that information from your table to the information on the next page, which is, I believe, page 202. The last page was 201. 202. Calculate the skateboarder's rate over the intervals indicated by the 3 parts of the graph. So, rate for the interval indicated by part A. So if we go back up to part A, all the way up to part A, was from 0 to 3 seconds. 0 to 3 seconds. At least we have this part done, on my table anyway. 0 to 3 seconds. How much time passed? Well, 3 seconds passed. And how much distance was covered? Well, let's see here. That is a total of, that's 7 minus 1. That's 6 feet total. 7 minus 1. Anyway, and this would have been, 3 minus 0. But let's not get ahead of ourselves. Let's go up here, and it says the rate for that interval. Remember, when we want to find rates and we're dealing with distance and time, it is always, remember, distance over time. And distance is measured on the y-axis, so we want to find the difference in the distance. So the rate is going to be the change in y over the change in x. So the change in the distance divided by the change in the time. And for part A, the last part of part A was 7 feet, and it began at 1 foot from the motion detector. And the time was 3 seconds minus 0 seconds. So remember, this is feet and this is seconds. Okay? 7 minus 1 is 6. So that's 6 feet. In 3 minus 0 is 3 seconds. So 6 feet in 3 seconds. Well, we need to simplify that. That's going to be 2 feet in 1 second. Or you would say just 2 feet per second. And that's the rate, 2 feet per second. And it's very important that when you're doing rates that you have to label your units. In this case, 2 feet per second. Now, given that information, you should be able to give the rate for the interval indicated by part B and by part C. So You go ahead and do that. Pause the video while you finish that up, and we'll get back to you when you're done with that. Okay, now that you have completed that, let's go on to the next page. And I believe this will be page 203 in your math book. This table shows data from a different skate in front of a motion detector. We're going to use this data to answer the following questions. Where did the skateboarder begin, and how do you know? Well, it's pretty easy to see where the skateboarder began because at 0 seconds, he was 5 feet from the motion detector. 5 feet from the detector. Learn to spell. Detector. There we go. And what do the data indicate about the direction in which the skateboard was moving? Well, if you watch the skateboarder's distance from the motion detector as time marches on, you can see he's getting farther away from the motion detector, and then he begins to get closer to the motion detector. So if we were going to graph this, it'd probably look like, it would probably look like this. It's going farther away and then getting closer and closer and closer. So we've got that going for us. Assuming the skateboarder was moving at a constant rate during the first 4 seconds, what was his rate? Okay, the rate during the first 4 seconds. So we're going from 0 to 4 seconds, and then that would be from 5 to 7 feet. So remember, let's do this. It's always distance over time. And we're going to find the change in the distance. The change in the distance was at the farthest point, it was 7 minus 5. And then the time is 4 minus 0, and that's feet and seconds. 7 minus 5 is 2 feet, and 4 minus 0 is 4 seconds. So 2 feet, 4 seconds. Let's simplify that. That would be 1 over 2. That would be 1/2 of a foot per second. Yes, 1/2 of a foot per second. Now, assuming the skateboarder was moving at a constant rate during the final 6 seconds, we would be going from there to there, and from there to there. Let's take a look at what that looks like. Remember, it's always distance over time. So the distance is, remember, at the end of it, it was 1 minus 7, and that's in feet. And the other part is 10 minus 4, and that's in seconds. 1 minus 7 is -6 feet. And 10 minus 4 is 6 seconds. -6 feet over 6 seconds. We can simplify that. That ends up being -1 feet per second. -1 feet per second. Okay? All right. On this last one here, not last one, I shouldn't say that. On this one, number 4, Terrence and Hosny each rode their skateboards in front of a motion detector. You'd think they'd have better things to do. Anyway, the graph shows the data from Terrence's skate, and the table shows the data from Hosny's skate. Assume, and we're looking at these, you can see this, the graph is from 0 to 8 feet and from 0 to 10 seconds. Assume Hosny moved at a constant rate for the entire 10 seconds. Which skateboarder was moving at a greater rate? And how do you know? Well, in order to figure that out, we're probably going to have to, it's obvious to see that Terrence was moving at a constant rate because his line is a straight line. And it says that Hosni was moving at a constant rate, so we're going to have to figure that part out. So we have to calculate the rates for each of those. Now Terence, he started at here and ended here according to the graph. So his rate is, remember it's always distance over time. His distance, the difference in the distance, he ended up at, looks like 7 feet. And we subtract 2 from that because he started at 2 feet. So 7 feet minus 2 feet over 10 minus 0. 7 minus 2 is 5. 10 minus 0 is 10. Oh, and that, remember, that's feet per second. So 5 feet in 10 seconds. That simplifies down to 1/2 of a foot in 2 seconds, or we just say that's 1/2 foot per second. That's Terence. Now for Hosni, his distance, he ended at 5.5 feet, so 5.5. He started at 3. His time was, his ending time was 10 seconds, his starting time was 0, and that's feet per second. 5.5 minus 3 is 1.5, and that's 10 minus 0 is 10 feet seconds. Okay, so let's do this. Divide both of those by 10. That would be 1 second. Divide by 10. Divide that by 10. And that would be 0.15 feet per second. So 0.15 feet per second compared to Terence's 1/2 a foot per second, which is of course the same thing as 0.5. So obviously Terence is moving at a greater rate of 1/2 foot per second. Okay. We look at number 5 here. And here's what I would recommend for this one is let's just graph Katrina's walk over Mason's walk. Easy to see. Katrina started at 0 seconds and she was at 2 feet from the motion detector. So 0 seconds, 2 feet from the motion detector. That's Katrina. At 3 seconds, she was 5 feet from the motion detector. 3 feet, 5 seconds. 3 seconds, 5 feet. Sorry about that. And then at 6 seconds, still 5 feet. Nice straight line there, not shaky at all. And at 10 seconds, 6 feet from the motion detector. 10 seconds, 6 feet. Okay, there you have it. Now it's easy to see what their similarities and differences are, but we're not going to spend the time writing that out at the moment. And question number 6, Selena and Brian were describing their motion detector walks to each other. Selena said, I started 3 feet from the motion detector and walked at a steady rate. Well, let's put her walk on the graph, okay? She started 3 feet from the motion detector. Here she is. She walked at a steady rate. After 4 seconds, she was 9 feet away. 4 seconds. 9 feet. Okay. I stopped for a second. 1 second. And okay. There's her stopping for a second. And then walked back. It took me 3 seconds to reach the motion detector. So from here, 3 seconds. 1, 2, 3, and she reached the motion detector there. Not the best line, but it's good enough. And you can see their graphs are very different. Okay, you just need to be able to read and write these graphs. Very important for you to be able to do so. Okay, and so all you needed to do was complete these pages, and then you'll find an Agile Mind assignment for you to complete on the computer. All right, thank you so much. Have a great day. Don't forget to be awesome. See you next time.